Dah, doktor.
Okay. Right, so that is history. So we can see that in our society, problem with infections, etc., is an old things. And we keep on trying to find ways on how to overcome those problems. And we cannot do that without understanding our own body, our own way to overcome this resistance. And it is true that our body can recuperate, our body can repair itself. It has a very great capability to repair itself, regenerative power. If there is any problem with the body, it can overcome the infection, etc. But in certain cases, just taking good diet is not enough. It's not enough. We can try to increase through food, etc. We can try to increase our immune system, but in some cases, the food need to be formulated into medicine. Dia tak boleh setakat makan suplemen je. In some cases, the immune system has been overcome despite very good diet, very good hygiene. And in cases where infection has take place, we need to take medicine. And in certain cases, even the medicine doesn't work, we need to look at other ways, such as vaccination, or even maybe amputation and transplantation even, to overcome the problems. So when we talk about immunology, one of the terminologies that we will come across often is immunity. In the simplest term, immunity is a state of resistance to infection or invasion. Infection or invasion. But I've mentioned in the beginning that this must be discussed in terms of non-self and self. Looking at foreign agent, not just bacteria or viruses, not just parasites, but also materials that are non-biological, dust, serbuk, debu, dust, can also be something which is non-self and can mount or can initiate the body to mount an overreactive immune reaction. Okay, so there is the non-self and then there is the self. Okay, so the resistance that we are talking about here is directed against a particular type of invading agent, and body will react differently. Okay, there's one type of immune system which is general to everything, but the body also have specific mechanism for specific invading agent, specific non-self agent. Okay. I mentioned about the specific and the non-specific. Okay, and on occasion, the immune system activity may lead to tissue damage if it is prolonged. So the immune system, when or in the presence of a non-self agent, it will mount a response. Most of this response is inflammatory in its nature, inflammatory, keradangan. Okay, and we need the inflammation to occur, but the inflammatory reaction must be controlled. It should not be prolonged. Okay, if it is prolonged, then it can cause tissue damage. We see this in allergic disorders. We see this in hypersensitivity and also transplantation complications. Okay, so the branches that I talked about in the beginning. Okay, I mentioned about transplantation, cancer immunology, allergic diseases, and then autoimmunity. This one I haven't mentioned. This is what happen within our body that does not need the presence of non-self. Okay, I mean the invading non-self. Okay, this is when there is a failure in our own system to recognize self as self. Ya, dia tak boleh nak detect our own body as our own body. Instead, the system recognize our own body as non-self, and it will start attacking our own body. Okay, so that one is another branch of the immune system. Okay. So the recognition of the self and the non-self, how can this be achieved? Okay, how can this be achieved? Is through the ability of the body to distinguish characteristic proteins. Okay, that's number one. In the event, in other event, it's not the characteristic protein, but protein link components. Okay, this is what we see in vaccine today. The vaccine, the Pfizer vaccine, it's not the protein, but it is the mRNA. This is the protein link component. So we can use either the characteristic protein or any protein link components to recognize the self and also the non-self. Okay. Once this distinction has been made, the body will then stimulate certain lymphocyte, a specific one, to produce antibodies directed against the foreign matter. And other type of antibody lymphocytes, they do not produce antibodies. Rather, they are being sensitized to invading agent and can react directly. So when we talk about the direct reaction, there are a few types. Yeah, there is the opsonization, and then there are also bursting mechanism. The lymphocyte basically, the cells basically explode, yeah, and expose its internal content that can be destructive to the agent. Okay. Okay, so what are the agents that could be presented as non-self? Yeah, I mentioned virus, bacteria, parasite, fungi, foreign substances like drugs, medication, okay, transplant organ, dander, which is the fur from animals, and then pollen also can cause can be presented as non-self. Okay. Okay. So when we want to recognize self versus non-self, we mentioned about in passing. Yeah, actually there are two major branches of the immune system that are involved. Firstly, the antibody-mediated immunity. Okay, we also call it humoral immunity, and then the other one is the cell-mediated immunity. Okay. Now, the appreciation that the body can recognize self and non-self was not there in the ancient time, but the people in those time, they know that if a person has been exposed to a particular disease, the likelihood that they can have the same disease again would be reduced. This one has been known since ancient Greek, for example. They wrote about it in their hikayat, in their epoch, in their stories, yeah, about how lucky is a person who has been infected with something and then recover. And this person would be selected to take care other people who are then newly infected with the disease. This is what they use or they recognize in the past. Okay? They recognize about the basic principle of the workings of the immune system. And then afterwards, because from this initial understanding, we use what we call variolation. Yeah, variolation. So variolation is you can say man-made mechanism to introduce something from an infected person to a non-infected person, so that the non-infected person will not get the disease. Okay, so variolation ni kita ambil pas ke apa ke, kita cucuk pada another person tu, but it has to be from the same disease. That was the variolation, the initial variolation. Okay, the method of immunization. We can regard it as the earliest method of immunization. Okay, but then in 1718, the method of variolation, or also called inoculation, was then brought to the UK. Before that, Europe did not know or did not understand the technique of variolation or inoculation. It was only introduced in UK in 1718 after she went to Turkey. There was a war there, Crimean War, and actually under the Turkish Caliphate, they already developed a very good nursing system, medical system. And this lady, Montagu, she was part of the British expedition. She saw what happened, what the Turkish nurses did, and she learned the technique and brought back the technique to the UK. Okay, so that was the start of the inoculation. It was also resisted in the beginning. Yeah, people resisted because it was a new method, and they were afraid because it involved introduction of an infective material to somebody who is healthy. Yeah? So they don't want to risk their healthy state. And then afterward, about 50 years afterward, 50, 60 years afterward, came Edward Jenner. Okay, this is a very interesting story, because Edward Jenner was pondering why the milkmaid, gadis-gadis pemerah susu lembu, the milkmaid, okay, why they have a very soft and smooth skin. In fact, there is a proverb, there is an English proverb which says, as smooth as the milkmaid skin. Sebab milkmaid skin tu, unlike others, if you remember the video I showed to you just now, the eruptions on the skin affected the whole body. Okay, so everyone, after they have, if they do not die, after they recovered, their whole body will be covered with pox scar. Very terrible, not nice at all. But the milkmaid, they have clear, no pox skin, very smooth one. So the English came with the proverb, as smooth as the milkmaid skin. So Edward Jenner was initially pondering about this proverb, and then when he saw the milkmaid, yes, their skin were smooth, there was no pox scar, etc. He then started to think that perhaps there is something that has been exposed from the cow, from the cow. Maybe the cow has a variant of pox virus, we call it cowpox, which then exposed to the milkmaid, and this then induced protection for the milkmaid against smallpox. Do you understand what I've been saying? Any questions so far? Okay. Okay, so that is the beginning of the modern immunology, with the vaccination that Edward Jenner brought about. The different in the method introduced by Jenner is that he used an agent from a different disease to induce protection against a particular disease in human. In this case, dia ambil daripada cowpox, ya, untuk protect against smallpox. Sebelum ni, kalau nak protect against smallpox, kita kena ambil material from smallpox patient, okay, cacar punya patient, untuk protect against cacar. Tapi the innovative step in Janus method, dia ambil daripada disease yang berbeza. Tapi masih agak sama lah. Okay. So in this case cowpox, kemudian digunakan untuk melindungi daripada jangkitan smallpox. Okay, this was not the method was not used before Jenner. Itu je beza dia. Okay, so that started the history of immunology. So people got interested in studying more about immunology, and then immunology also, another subject that is closely related to immunology is microbiology. Okay, Robert Koch, for example, started to discover microorganism. So during the time of Jenner, 1790s, we only appreciate that there is something in the substance that can cause disease and also provide the protection. But what is this substance? We do not know, because at that time there was no microscope. Okay, there was no method to do glass slide staining. Ya, kita tak tahu macam mana nak buat glass slide. So we could not see all these microorganism. It was only in 1800 plus when we managed to develop microscopy technique. Then we start to see, oh, actually in the substances there are other biological materials, benda-benda hidup yang seni, yang kecil, ya, bacteria, viruses, etc. Like the pox, smallpox, cowpox, these are viruses, ya, pox viruses. And then 1880s, Louis Pasteur devised vaccines against cholera in chicken and against rabies. And then 1890s, von Behring and Kitasato, this is Japanese, independently they discovered antibody. So we started to understand more about our own immune system. Okay, so these are the impact, of the vaccination program, which came about from a better understanding of the immune system of our body. So 1965, okay, this is for smallpox. Okay, 1965, we can see that the number of countries with one or more cases per month is high. But 1970s dropped, and finally in 1890s, there's no report of smallpox. Okay, so yang ni, this graph ni is corresponding to the time of smallpox vaccination being introduced. Okay, from 1965, so kita nampak dia jatuh, and then the smallpox vaccination program becomes encouraged by WHO and adopted by many more countries. So we see more reduction in the smallpox case. By 1975, 5 years, for 5 years, there was no smallpox cases being reported, and it was announced in 1980s that we have managed to eradicate smallpox. Yeah. So although we use the word eradicate, we know that the virus is there, but the community, the human community all over the world, yeah, they have developed protection against smallpox. Okay, if we look at other diseases, diphtheria. Okay, diphtheria is another very bad disease. Kalau tengok dalam manuskrip pun ini batuk kokol, another problem that they always mention. So all ancient diseases. So 1900 to 1940s, the prevalence is high, and only when we start to give vaccine in 1940s, we see a drop, a very significant drop in diphtheria cases. So within a period of 10 years, almost zero case of diphtheria. And then pertussis, no, not polio first. Okay, polio. So we have the two types of polio, the inactivated vaccine and also the oral vaccine. So the cases increases. So for polio, mula-mula kita bagi vaksin, so the case drop, but then we see increase in numbers between 1940s to 1950s, and then we give the inactivated vaccine, it dropped again, and then there was a spike, and this spike was thought to be due to some of the inactivated polio becoming activated. And then we then develop the oral vaccine, give to the site, to the community, and then we see the case of polio significantly and being sustained at a very low rate. Measles, measles. So measles, presentation of measles, one on the skin and the other one is actually in the brain. Anyone who receive or being infected with measles, there is a lag of about 10 years before they could then develop the brain presentation. So this is what we see when we give vaccine. Okay, ini orang yang kena 1960s, they will develop the panencephalitis in 1970s. So you see the numbers here, they then develop the panencephalitis here, kan? And then we give the vaccine in the middle of 1960s, we start to see drop, drop in the case of the panencephalitis as well. Then the number of the measles continue to drop. Accordingly, the number of panencephalitis also continue to drop. But there is a lag in the reduction of the measles. Anyway, the vaccine for measles has been shown to correlate very well with the reduction of the both measles and also the panencephalitis presentation of measles. Okay. How many more? Okay. I think there are two more slides before we stop. 12:50. Okay. Now we continue next week. So, this is just to recognize the importance of immunology and also the importance of antibodies. So when we give vaccine, for example, this is actually coming out from the understanding of how we can stimulate the bodily system, the immune system of the body. When we give vaccine, the body will be, we don't have to wait for the natural infection to occur. We can expose the body to the non-safe. Vaccine is basically the non-safe form of the infective agent, of the invading agent. The non-safe. Dia tak ada benda-benda lain lah. The main thing about vaccine is the non-safe agent, by which we can then stimulate faster our immune system. The aim is to produce antibody. This is the major aim, to produce the antibody. We mentioned about the non-specific, the specific, and then the non-antibody reaction. But actually, the major thing that we want to get from giving the vaccine is the antibodies. And we know that the antibodies, once a good number of antibodies has been produced, they become memory cells, and this is actually the memory cells that then protect again the occurrence of the disease in the next infection. Okay, so the vaccine is, again, I would like to reiterate, is a kind of non-safe, and then we artificially induce the infection by giving the vaccine. Jangan pula cakap lepas ni saya cakap vaksin ni satu jenis jangkitan pula, tak. Saya nak cakap dia seperti seperti kita menjadikan jangkitan tu berlaku pada badan. Dia bukan yang sebenar-benar jangkitan. Okey, kita hanya bagi the non-self ni masuk ke dalam badan kita. Kita simulate the infection and then we stimulate the immune system in a very controlled manner. Okay, so kita sampai badan itu mendapat jangkitan yang full blown infection ni. Okay, and then the body will then produce its own antibody, and the pool of antibodies, memory cell that can produce antibodies in the body, this is the one that actually protect against the next occurrence of the infection. Okay, I could take any question from you before we stop here. If you have any question. Ya. Talking, siapa ni? Syahmi Syahmi. Okey.
Macam doktor, kalau orang tu dah sakit.
Saya sebenarnya tak berapa dengar suara.
Oh ya. Kalau macam orang tu dah terkena sakit, betul, kalau cakap vaksin COVID-19 kan, orang yang terkena COVID-19 tu, kita bagi vaksin COVID-19.
Okey.
Boleh bagi kat orang yang sakit, boleh bagi kat orang yang sihat ke yang dah sakit tu.
Vaksin is a preventive treatment, dan memang kita bagi kepada orang yang tak sakit. Okey, tak sakit. Dia saya ulang balik Saya cakap Melayu tak apa ke? No international student here.
Boleh tak ada international student.
Jangan pula cakap lepas ni saya tak cakap Inggeris ke apa ke ni. Don't make it an issue Okay. I will talk in English and then I also talk in Malay. Okay. Okay. For every disease, there are two types of diseases. One type of disease, once you get it, after that you don't get it anymore. Okay. Dan yang jenis ni sikit sebenarnya. Contoh macam flu ataupun sesama. Sebenarnya kita kena satu kali sesama ni, virus dia yang menyebabkan sesama sebenarnya ada banyak varian. Tapi sekali awak dah kena dengan satu varian, insya-Allah bila varian yang sama menjangkiti awak takkan kena lagi sesama tu. Okey. Tapi kalau awak kena dengan varian yang lain, awak akan kena balik sesama. So sebab itu sesama ni susah sangat nak treat dia sebab dia sentiasa varian yang berbeza. Okey, tapi dia kadar jangkitan dia tak teruk. Maknanya lepas 2-3 hari awak okey balik kan. Tanpa treatment pun awak akan okey balik. Okey. Jadi masa awak kena sakit tu, kita bagi ubat ataupun awak rehat dah selesai. Perlukah kita bagi vaksin? Kes yang macam ni tak perlu bagi vaksin because you can recover on your own. And then for most people, close to 100% of cases yang sesama ni memang dia takkan jadi teruk. Unlike COVID-19. COVID-19 for quite for some people, although the percentage is not very high, tapi bila dia kena tu, dia jadi sangat teruk sampai boleh mati. Maka kes-kes yang macam ni kita kena fikirkan kaedah seperti vaksin. Sebab dia boleh kadar jangkitan yang sangat cepat. Kalau saya kena sesama je, orang sebelah saya mungkin tak kena pun, takkan jangkit pun. Tapi COVID ni lain. Ada punya kadar jangkitan dia tu agak tinggi. Okay? Dan degree of infection tu can be very bad. Walaupun minority saja, tapi dia very bad. Dia kita kata worth for us to find a vaccine for it. Okay. Okay. However, by and large, a vaccine is a preventive measure. Preventive measure. Okay. Kalau orang tu dah kena COVID-19, boleh ke kita bagi lagi vaksin? Boleh. Sebab COVID-19 ni dia walaupun dah kena, orang yang dah kena tu dia masih boleh dapat lagi. Kenapa dia masih boleh dapat? Sebab kadar induction of the immune system yang boleh produce antibody itu tak cukup banyak. Faham ke? Tak cukup banyak. Kita hanya akan boleh mempertahankan diri kita daripada infection yang lain yang luar ni sekiranya dalam badan kita sudah ada cukup banyak sel untuk pertahankan diri tadi. Kadang bila kena infection tu dia tak cukup banyak being stimulated. Okay? Jadi the second infection can still occur. That's why like COVID-19 Pfizer tu pun we have to give booster because the first one tak cukup lagi untuk sustain the immune reaction. We need to give a second one, another booster, and then at that time dia punya level of the cell can cover against the infection. Am I answering your question?
Yes, Doktor.
Okay. Cuma saya personally I still feel that we still need to also investigate if we can give treatment, medical treatment. Sama ada bentuk pil ke, bentuk minum ke, bentuk yang hidu ke, on top of the vaccination program. And I think if you ask me, I feel that the scientific community mungkin kita agak kurang, we have not given enough emphasis and enough study on the medical treatment, and there has been quite a lot of emphasis on the vaccination. Itu je lah saya punya ni. Okay.
Assalamualaikum Doktor. Nak tanya juga. Boleh ke?
Boleh.
Saya interested dekat introduction Doktor mula-mula tadi about traditional treatment tu kan. Macam old people, even kita dah cakap like modern treatment and traditional treatment, dia lebih kurang sama je. Macam traditional, is it healthy? Yes, but you still have problem to heal some disease. But macam for other people, kalau nak bandingkan traditional and also modern treatment tu, diorang maybe akan cakap like better ambil traditional treatment sebab kita tahu dia natural and macam mana healthy rather than kita ambil synthetic from modern treatment tu, even though the progress might be slower or less effective. Jadi macam betul ke macam mana?
In my opinion, we have to take the good from both tradition, whether it is modern or it is traditional. Whether it is modern or traditional, if it is taken according to the way of or method of administration and according to the correct amount, it should be okay. It should not be detrimental to your health. Okay. Yes, I think I agree that certain medication, modern medication, it could be quite strong, and when we take it, it could have a immediate deleterious effect. Bila awak makan dia terus jadi ni mungkin bagi kebanyakan orang. Betul, memang ada ubat-ubat yang macam tu. So you have to take it in a controlled way. Contoh ubat apa? Ubat warfarin contohnya. Ubat warfarin untuk orang stroke. Untuk orang stroke, they have to be assessed, monitored from time to time. Okay, kita bagi ubat satu dos ni untuk orang stroke. Mak saya sendiri adalah patient stroke, so saya tahu this particular time the doctor give this particular dose, mungkin dia okey untuk beberapa hari, tiba-tiba hari yang berikutnya tu gusi dia berdarah sebab ubat tu telah mencairkan darah mak saya, dia tak boleh membeku, jadi dia keep on bleeding. Dan dia kena pergi ke hospital, tengok balik, ubah balik dos. Okay, so yes, modern medicine ada ubat-ubat yang macam ni yang susah kita nak gunakan. Kita kena monitor very well. Okay, but there are also very safe modern medicine like Panadol contohnya, very safe. Ya, banyak lagi lah yang safe. Ya, dan yes, it's true that modern medicine, some modern medicine kita pun kritik. Ya, kita pun kritik that certain medication does not really cure. In fact, once kita bagi pada patient terpaksa pakai sepanjang hayat. Contoh ubat diabetes, ubat hypertensive medicine. Ya. So ini adalah limitation yang kita kena agree, kita kena acknowledge, and this is your role, this is my role, researching to find a better medication. Ubat-ubat tradisi pun macam tu juga. Ada yang sangat baik, ada yang sangat simple. Banyak je ubat tradisi yang kita masih pakai dalam modern medicine. Okay, banyak je ubat tradisi yang modern medicine memang tak boleh nak kata apa. Contoh gamat, gamat kita letak kat luka, you don't have to make it modern macam mana. You memang, kita tengok penyediaan dia tu memang very traditional. We take the gamat, which is a type of animal, sea animal, we put it in the periuk yang besar tu, kita kukus dia jadi minyak dia, kita campur minyak sawit semua, jadikan minyak dia tu, and then kita sapu. We don't have to produce in macam mana preparation yang sangat hebat macam mana. We just make it into oil, and then we put it on our wound, and it's memang cure rate very high. Siapa boleh ignore that fact. Okay, haruan pun sama juga. Kalau kita makan haruan, our healing rate is very high. So ada ubat-ubat tradisional yang macam tu, very very good. We can't say against them. But of course, ada juga ubat-ubat yang sangat ubat tradisional yang sangat toxic. Dan dalam manuskrip, contohnya dalam manuskrip memang dia sebut this particular formulation should not be taken by people who are pregnant, dia kata, indicating that particular formulation, traditional formulation, is strong. Ada jenis-jenis akar, contoh akar celaka. Nama pun akar celaka. Nama pun akar celaka. Kita pakai dia untuk apa? Untuk kes seperti contoh anak mati dalam perut. Anak mati dalam perut. Macam-macam orang boleh jatuh, anak dia cedera kat dalam perut, mati. So macam mana kita nak buat keluar? Kita pakai akar celaka ni bagi untuk dia akan keluarkan anak tu. Ada juga untuk orang yang nak menjarakkan anak, kita boleh bagi formulasi akar celaka ni. Tapi akar celaka ni tak boleh sebarang orang pakai. Kena bidan yang mahir. Sebab kalau bukan bidan yang mahir, pakai this akar celaka, boleh jadi mandul terus. Okay, so in some cases it's very effective, but it has its own precautions. So WHO actually since 2012, kita sekarang ni bawa a new paradigm, which is integrative medicine paradigm. We look at what is old and what is good in the old. We look at what is good in the new, in the modern, and we take what is good in both tradition. Okay, that is our paradigm now. Okay, so kenapa cakap pasal benda ni? We are talking about immunology, but I know it's a big issue. But we are learning about the theory, but the theory is very strongly linked to the practicals, to the practice. One of the hot issues yang we have is vaccination program. Okay. So we had talked about this, all this paradigm shift that is happening, so that we understand better, well informed about everything. Okay. Another question? Okay, just to summarize, ya. So immunology bukan sekadar nak tengok macam mana kita melawan penyakit, tapi juga sebenarnya dia nak menengok cara kita recognize self versus non-self. And this non-self is not only infective agent, it could be things as simple as pollen, fur, debu. It could be also very useful to think about when we talk about diseases or condition like transplantation. Transplantation. So kalau nak ambil organ daripada orang lain, imat nak bagi kat saya contohnya. Jadi saya nak tahu boleh terima ke tidak ni. Ini actually di sinilah immunology memainkan peranan. Okay. Dan untuk tahu non-self versus self ni, macam mana badan kita tahu adalah dia dengan mengenal pasti, identify specific protein or protein that is linked to the agent tu. So kalau imat, my body will reject imat if my body can recognize that this is imat, not Affendis. Ini organ imat ni. Jadi imat ni bukan saya, jadi saya kena reject dia. Jadi macam mana nak overcome this? Adalah cara dia, nanti kita akan bercerita dalam transplantation immunology lah benda tu. Tapi the point is here, the rejection occur because the body recognize the organ tadi ni as non-self. Okay? So it's not just bacteria, viruses, yeah. And then if I have allergy, why do I get this allergy? It is actually because of this non-self versus self problem or issue. And we also learn about the history, macam mana kita belajar tentang immunology ni, recognizing appreciating what is happening, macam tadilah Jenna tengok apa jadi pada pemerah susu, kemudian dia bertafakur about it and come with the idea. So actually we also scientists, we have to look back into our literatures, hikayat kita, peribahasa kita. Saya ada tulis satu buku sebenarnya, Sudah Gaharu Cendana Pula. You can Google for it, where I take all this proverb etc. and we give our interpretation according to the modern science that we know today. Kenapa orang Melayu cakap begini? Kenapa orang Melayu cakap begini? Ada sebab-sebab dia. Sama macam tadilah, Edward Jenner tadi dia tengok proverb English, the English proverb, as smooth as the milkmaid skin. So why does is there any truth? Is there any explanation behind the proverb? Okay. So all the scientists that I have in my class today, I hope you'll be the next generation of scientists who is not only studying science as science ni, but also scientists who are who can innovate things, by looking at their own indigenized materials, culture, etc. I think that's all that I would like to say today. We close our session with kita buka ke tadi dengan Fatihah, tak ingat. So anyway, we close our session with Tadbis Kafarah and Suratul As. Wassallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallim walhamdulillahi rabbil alamin. Hopefully I will see you next Monday, maybe about the same time. I hope no problem with the synchronous learning. We also do the recording, so you can also play around or listen to it asynchronously. I've given Farah apa tadi? Farah apa nama? Lupa pula. I've given to Farah the attendance link. Farah Nasirah, the attendance link. You just need to click once, time in. Senang je, tak payah nak time out, time in. Just time in je. I just need that one. I've opened it for 7 days. For 7 days. Kalau awak malah nak buat sekarang, awak buat Ahad, silakan. Okay. But please listen to the recording if you need to do so. Okay, thank you very much. Assalamualaikum.
Waalaikumsalam.
Thank you, Doctor.